So here we're going to talk about angle-angle similarity. And this deals with two triangles that are similar. You can have two triangles that are of different sizes, but they can have similar traits to them. So in order for triangles to be similar, all you need is two angles to be the same. That's it. As long as two of the angles match up in each of the triangles, that means the third one has to match up, and those two triangles are in fact similar. So let's look at this similarity statement here. This symbol means similar to. So triangle ABC is similar to triangle DEF. The order in which these are labeled matters because what this tells us is that the measurement of angle A is going to equal the measurement of angle D. So as long as if A tells me is 77 degrees, that means D better be 77 degrees or these triangles are not similar. It also tells me the measurement of angle B is congruent or equal to the measurement of angle E, which I see B is 58 and E is 58, so far that's a check. Also the measurement of angle C equals the measurement of angle F, which we don't know what C is, but we do know that F is 45 degrees. So here we go. We need to pick one of the missing angles, and it does not matter which one we pick. So I am going to choose to find angle C here. So we already know from earlier in this chapter that all angles inside of a triangle add up to equal 180 degrees. So that means that 58 plus 77 plus angle C, which I'll call X, should equal 180 degrees. And so now I'm going to combine my like terms, and I get 135 plus X is 180. Subtract 135. X equals 45. Boom. Since F is 45 and C is 45, there are my two angles. Angle B is equal to angle D, and angle C is equal to angle F. So yes, these are similar because the angle-angle theorem, angle-angle similarity theorem. Similarity theorem. Because two angles are equal in the triangle, so that means that angle D has to be 77 degrees. Okay, here we go again. Angle G and angle J have to be equal in measure. I don't know what J is. Angle H is labeled second, so is angle K. Angle H has to equal angle K in measure. I don't know what angle H is. And I has to be equal to L. And both are 33. So that one checks. So we either have to pick to find J or we have to pick to find H. In this case, I'll pick to find H. It doesn't matter. You can pick J. You'll get the same answer. So I have 33 plus 26 plus X equals 180. So I have 59 plus X equal to 180. Subtract 59. X equals 121. So the measurement of angle H is 121 degrees. So H and K are equal because they are both 121 degrees. Therefore, G and J have to be equal. So here is why those two triangles are similar. So that is true. All right, here, can we conclude that ABC is similar to DEC? So A, right here, is marked, and D is marked. Those markings mean those angles are the exact same size. So these are the exact same size. Now, there's a few things we can tell from this. If we look here, we have two angles cut by a transversal where the alternate interior angles are congruent or equal. Therefore, we have parallel lines right here, which means these angles, the measurement of angle B equals the measurement of angle F. But if you look, C is in both of them, right? C, this is a vertical angle. The measurement of angle C equals the measurement of angle C because of vertical angles. Therefore, these two triangles are in fact similar. Here we go again. We have markings. This is a 90-degree angle, and this is a 90-degree angle. So we only need to show that we have one more angle the same. And because vertical angles are equal, or are congruent, the measurement of angle, now I'm going to call it JH I is equal to the measurement of angle FHG. The reason why I did that is I started at J, went down to H, and went to I. This angle right here, you have to follow the order in which these are labeled, and the order in which they are labeled matters. As we talked about earlier, F has to be equal to J, okay? G has to be equal to I, and H has to be equal to H, which H is equal to H, as we showed right here, because of vertical angles. You could have also said alternate interior angles because these are parallel. So we know that these are, in fact, similar. All right, let's circle true or false. Here we go. So we're going to start at L, go to M, and go to P. So this little triangle right here, they're saying is similar to Q, M, and N. Well, I know M. I know that these are similar because those are vertical angles. And then L right here and 43, when you add those up, that equals a straight line. So that's 180 degrees. So I know if I take 180 minus 43, 137, that's what I get there. Well, look here with Q, the same thing. That equals a straight line, so this is 137. So yes, this is true because you have two angles in each of the triangles that are equal in measure. Let's go to the next congruent statement. I have LMP again, and then I have R to P to Q. Well, I know that this is 43, right? I know that P is equal to P because it's the same angle in both triangles. I also know that this angle right here is, what do we say, 137? Okay, so right now, this is all the information I have. I don't have enough information. I cannot find this angle right here to tell me if that equals 43 degrees. I cannot find this angle right here to tell me if that equals 137. So this is false because we cannot find any more angles than what we just found. Next one, we have triangle R to P to Q. Now I am following the order in which they are labeled here. That's how we follow these triangles, R to P to Q. And then I have R to L to N. Whoop. Are these triangles similar? So what this tells me, R is in both, right? This tells me that angle R is equal to angle R. That is true, okay? So check. Angle R is equal to angle R. Then P down here has to be the same as angle N right down there. Possible? Don't know for sure. Let's check this last one. Angle Q is 43 degrees. Angle L is also 43 degrees. Check and check. I have two checks on both. This one is true because I was able to find the measurement of two angles in both triangles to be the same. Last, Q to M to N, this little guy, and then R to L to N, this big guy. probably not going to be able to find enough here. I know that N is in both of them. So there's my one check. Other than that, I cannot find any other angles. I know that L is 43 degrees, but I know that Q is 137, but that's all that I can really find. Therefore, this is false, because we cannot find more than two angles in each. So, let's see which one of these is true. A, start at A, to Z, to R. Then we go A, to K, to L. I know that A is in both, check and check. A is the same in both. And then I see that R is 24 degrees, and L is 24 degrees, check, check. This statement is true because we found two angles in in each triangle to be equal in measure. Now let's go to the next one. We have Z to G to L, so the little triangle here. And then K to G to R, this little triangle here. So R is 24 degrees. L is 24 degrees, so there's the same in each. Check this one out. G and G, these are vertical angles. Because vertical angles are always equal in measure, these two triangles must be similar because two angles in each triangle are the same measure. And let's check out this last one here. Whoa, that's a big point there. So if I go A to K to L, remember we have to follow the order in which the triangle is labeled in the statement. And then I go G to R to K, the little one here. R is 24, L is 24. These are different K's, so the K's do not match up. Okay, maybe I should do this triangle in a different color to show the two different triangles we want. This K right here does not match up to this K right there. Those are not the same. So we cannot conclude enough information here. So 1 and 2 are the only two statements that are true.